x that will satisfy the equation. This is the equation tan of x minus 30 degrees is equal to 1 over root 3. Okay. So, and the domain, this is the domain. We are interested in all the answers from 0, including 0, right up to including 360 degrees. So, we need to work out this equation. So, dealing with the tan graph, let me just explain to you what's going on here. Okay, so you have a tan graph. I just want to show you the tan graph graphically, because as you come higher up to level N5 and N6, it's all about sketching your graphs and understanding what is going on the graph. Right, so that equation actually represents what is happening to the tan graph. Okay, so let's take a normal tan graph first, tan of x. So your normal tan graph, we got 0, 45, 90, 135, 180, 225, 270, 315, and then 360 degrees. Okay, so you have this one here is 45 degrees, 90, 135, 180, 225, 270, 315, 360 degrees. I just want to show you a normal tan graph. Okay, so at 90 degrees, you're going to have an asymptote there. So let's have a look at your tan graph now. What's happening? When x is equal to 0, y is equal to 0. Then when x is equal to 45 degrees, your y value reaches 1. And as you get closer and closer and closer to 90 degrees, the graph goes, it increases, it goes higher and higher. So, if this is your shape of your tan, this is one curve here going up. It comes very close to 90 degrees, but it does not touch 90 degrees. As the graph approaches 90 degrees, the y value approaches positive infinity. Okay. Then, what's happening here at 135 degrees? Check, what is tan of 135 degrees? Tan of 135 degrees is? You should get minus 1. What is tan of 180 degrees? 0. Tan of 180 degrees is 0. So there's one cycle here. Okay, now this pattern will repeat itself. So there's one cycle. So the same thing is going to happen here now. So at 225 degrees, you got 1 again. And at 270 degrees, what's happening at 270 degrees? You get an asymptote there again. So you have your asymptote there, so it's coming close there, but it does not touch. At 315 degrees, what's happening at 315? Negative 1. At 360 degrees, what's happening at tan of 360 degrees? 0. So, there is your graph. This is a graph for y is equal to tan x. Okay. Now, let's compare this graph with the graph that we are given here, tan of x minus 30 degrees. Okay. So how does that affect the shape of the graph. When now x is being replaced by x minus 30 degrees, what's happening there? Now remember, here, when I put down 0, tan of 0 was equal to, put tan of 0 here, what do you get? You get 0, then tan of 0 is 0. Then tan of 45 degrees, 1. Now, let's look at our new equation. We have y is equal to tan of x minus 30 degrees. Now, type this out and put 0 there, what do you get? Minus 0,577. Put 30 degrees, what do you get now? Replace x with 30? 0. Okay. So what do you notice now? That when you substitute 30 degrees here, you're getting a y value of 0. When you substitute 0 here, then you're getting 0. Okay. So now, this graph here, the same y value that you got here, in order to get the same y value here, you need to start off with x equal to 30 degrees now. So this graph, basically what is happening here is, it is being moved 30 degrees. In which direction? To the right. 30 degrees to the right. Okay. So now, this graph will start at 30 degrees. So let's say that this is 45 here. So let me just carry on at 45. This one is 90, 135, that is 180, 225, 270, 315, 360. Okay, that was the domain. And these were all the critical values for y is equal to 10x. But now, what do you notice here? We are stepping every 45 degrees. Can you see that? So we got 45, 0 plus 45, plus 45, plus 45, plus 45, plus 45, until we come to the end here, which is 360 degrees. But now, we are starting from 30 degrees. Let's say 30 degrees is here. Now, if I add 45 to 30 degrees, what will I get? 75 degrees. If I add 45 to 75, what will I get? 120. If I add 45 there, give me all the values until I keep on adding until I come to it. So 120 plus 45 is? 165. Plus 45 is? 210. Plus 45? 255. Plus 45? 300. Plus 45? 345. Plus 45? 390. Okay. Now, what did you, if you look at the original graph, we had 45 plus 45 at 90 degrees. Okay. After two-step values, we had an asymptote there. So if we're starting at 30, we'll count 1, 2. So your asymptote will now be at 120 degrees. So there's your asymptote here at 120 degrees. Then what happened here now? You counted 1, 2, 3, 4. After 4-step values. So there's a chart. You're going 1, 2, 3, 4. So now, at 300 degrees, we'll get an asymptote. Okay. So now, let's have a look at what's going on here. So we got 1 minus 1. Where are we starting from? Here we start from 0. This graph is shifted 30 degrees to the right. It's just like taking everything here and shifting it 30 degrees to the right. So let's see how it's going to look. So we're going 30 at 0. At 75, what do you get? What do you get when x is equal to 75? You get 1. You must get 1. If you're not getting 1, check you're not substituting properly. Okay, remember, we're substituting into the original equation. Right. So, at 75 degrees, you're getting 1. And then now, it's going there. So, what's happening at 165 degrees now? If I put replace negative 1. Then at 210 you can see now what will happen here. So it's going down. There at 225, what do you see happening at 225? You must get positive 1. Are you getting it? Alright, and at 345, what are you getting at 345? You must get negative 1. At 390, what are you getting? 0. Although we're not supposed to be sketching up to 390, but I'm just showing you the phase shift there. Okay, so yeah, now remember this graph here is going to be carrying on and passing through 0. Because we have to start from 0 and we're stopping at 360 degrees. Now, what I'm showing you here is just a picture of an original sine graph and a sine graph, an original tan graph and a tan graph that has been shifted to the right. You must understand how to shift the graph to the right, to the left, also up, that will be vertical and down. Now, tan of x minus 30. What is the equation that's given to us? Calculate the values of x that will satisfy the equation for from 0 to 360 degrees. We want to find out where is tan of x minus 30 equal to 1 over root 3. First of all, what is 1 over root 3? What is 1 over root 3? Round it up to 3 decimal places. Work that out. What is 1 over root 3? Round it up to 3 decimal places. 0,577. Okay, now, where is tan of x minus 30 equal to 1 over root 3? In other words, where is this graph equal to 0,577? So now let's look for 0,577. Okay, that means the y value now is replaced with 0,577. Understand what I'm saying? So where is 0,577? If this is 0 and this is 1, maybe 0,577 is around just above halfway. Can you see that? Now, sorry? And it's a positive there. You can see that positive 0,57. So here it is. You saying something? So that will be 0,577. Now, what you will do is, you take your ruler and you draw a horizontal line, because this is representing a y value only. So it represents a horizontal line. So you take your ruler and you draw a line across. So, how many places does this line intersect the tan graph? 2 places. Can you see that? So it's intersecting here and here. Okay. Now, these are the graphical solutions to this problem here. So now, when you look down, what is the x value at that point? It's 45 degrees. Can you see that? So, That means one solution is where x is equal to 45. Now it might not be 100% according to I'm just doing a rough sketch on the board, yeah? Okay. So let's look at where the other solution is. Where is the other solution? Here. What does it look like to you? It looks like 225 degrees. Can you see that? Now, this is called a graphical solution to this trig equation. It's all about where is the tan graph intersecting the straight line 1 over root 3. Now, let's do it algebraically. Okay? Which is what is required in your exam. So we got tan of x minus 30 degrees is equal to 1 over root 3. So now, let's say you forgot how to sketch a tan graph. But what you remember is the shortcuts. The shortcut is to draw a cast diagram. So that will be C, A, S, T. So you know that this is the first quadrant, this is the second quadrant, that's the third quadrant, that is the fourth quadrant. Cast diagram must be in your head. So now, this cast diagram is just a shortcut method for you to identify where all the graphs are positive. And where they are not positive, they will automatically be negative. So now, this is a positive 1 over root 3. Can you see that? So in other words, now how do you use this? You go to your cast diagram and you check which two quadrants is the tan graph positive in. Which two quadrants? The tan graph is positive in the first quadrant because when you read this, read it, what does it mean? It's not just all, it means all the graphs, all your trig graphs are positive in the first quadrant. So when you're learning this, you don't just say all. It means all the trig graphs are positive in the first quadrant. You need to say the full sentence there, right? So now, what does the S mean? It means only sine and 1 divided by sine are positive in the second quadrant. Here, T, it means only tan and 1 divided by tan are positive in the third quadrant. So we are interested in where is tan positive. That will be all graphs are positive in the first and only tan and 1 divided by tan, which is cotan, is positive in the third quadrant. So your solutions will be in quadrant 1 and quadrant 3. Your solutions will be in quadrant 1 and quadrant 3. So, in quadrant 1, so how do you do this here? Okay, you're going to go x minus 30 degrees is equal to inverse tan of 1 over root 3. Okay, plus k 180 degrees. Now, why am I saying k 180 degrees? Because the same thing happens every 180 degrees. Let's go back to the original tan graph. Look at 45 degrees. What is the y value at 45 degrees? It's 1. Add 180 to 45. What do you get? 225. Look at 225 degrees. Go up. What is the y value at 225 degrees? It's still 1. That means the same thing will happen every 180 degrees. It repeats itself. So that's why the general solution for tan, you put plus k 180 degrees. Okay. So if you write it like this here, you are already covering the third quadrant. Okay, you can just write down one solution, but let me just go according to a normal way. Quadrant 1, quadrant 3. Quadrant 3, what do we normally do in quadrant 3? So you're going to go x minus 30 is equal to 180 plus inverse tan 1 over root 3 plus your k 180 degrees. Can you see that we are repeating the same thing? Can you see that? So So it's actually unnecessary. When tan is positive, it's actually unnecessary there to go and write it twice, but let's just do it. So now, what do we have here? We got x is equal to inverse tan of 1 over root 3 plus 30 degrees plus k 180 degrees here. Here x is equal to 180 plus inverse tan 1 over root 3 plus 30 degrees plus k 180 degrees. So what do we get here? Inverse tan 1 over root 3? 30 degrees. So 30 plus 30 is 60. So this is called a general solution. At the moment, this is just a general solution. So I need to find out x. I want a unique solution, a particular solution. That means we are not interested in everywhere, in all the places where the graph reaches 1 over root 3. We only want to start at 0 and stop at 360 degrees. So what we do is we will substitute values for k. So let's put when k is equal to 0. If I put k equal to 0, what do I get? 0 times 180 plus 60 is 60 degrees. Okay. Then if I put k equal to 1, what will x equal to now? 240 degrees. Okay. If I put k equal to 2, what will I get now? That will be 360 plus 60, which is going to be 420 degrees. I can put k equal to, sorry, this one k was equal to 2. I can put k equal to 3, k equal to 4, k equal to 5, and I'll get an infinite number of solutions here. The question is, which one is not required? 420. Why is it not required? Because we have to stop at 360 degrees, so this one here will be not applicable. So 60 degrees will be right, 240 degrees will also be correct. Okay, you will notice that you will get the same answers here. Because of the plus k 180 we are repeating. So 180 plus 30 is 210 plus 30 again 240 degrees plus k 180 degrees. So this one here, can you say it's the same thing now? If I put, let's say if I put k equal to 0, what is x equal to? 240 degrees. If I put k equal to 1, I'm going to get 420. Okay. If I put k equal to minus 1, if I put k equal to minus 1, what will I get now? If I put minus 1, 60 degrees. So x is equal to 60. Can you see that these two solutions are already worked out here? So because of the plus k 180. So you actually don't have to do it twice. Now, first of all, are these solutions correct? Did you check it? You need to take this, substitute into the original equation, check if the left hand side is equal to the right hand side. Take 60 degrees, substitute here, tan of 60 minus 30, tan of 30. Do you get it? It's correct. Check 240 degrees, tan of 240 minus 30. Do you get it? Yes. Okay, so our graph, because I'm not measuring now, according to the graph, it looks like 45 degrees, but it was not 45 degrees. What was it? It was 60 degrees. Okay. This one looks like, when we were from a rough sketch, it looked like 225 degrees, but it was actually 240 degrees. Okay. But if you had a question where you had to draw a graph to show the solutions, you will be marked correct there, because from a graph you can't be 100% certain on. It's just you are reading off the graph. So both solutions are correct. So that was your tan graph. Okay, the next question here, prove the following trig identity. This one is 6 marks. So we need to prove that the left-hand side is equal to the right-hand side. Let's have a look at the left-hand side, what we have here. So my left-hand side is equal to cos of 360 minus a. Now you should know this from your reduction formula. Your diagram, what is cos of 360 minus a? Let's just do it here quickly. So you know, we just did it now. That is 0, this is 90, 180, 270, and you get back to 360. That's quadrant 1, 2, 3, 4. That's C, A, S, T. What are we dealing with here? We are dealing with 360 minus your reference angle. This one here is going to be 180 minus your reference angle, and this is 180 plus the reference angle. Okay. You could also be dealing with co-ratios. Co-ratios, you will have 90 minus. Let me just use a different color there. This will be 90 plus. This will be 270 minus. And this is 270 plus. So the way we deal with the ones that I have in a block or rectangle, the method is different from the one that we deal with in fluid. Okay. So cos of 360 degrees minus a. How do we use the shortcut method, which is the cast diagram, to evaluate, to reduce cos of 360 minus a? First of all, we check which quadrant is 360 minus a. Which quadrant is it? It's the fourth quadrant. In the fourth quadrant, what's positive? Cos is positive, so therefore this can be written as just going to equal to cos of a. To understand what that means, you have to draw the graph to see why cos of 360 minus a and cos of a are equal. Okay, so the left hand side simplifies to just cos of a. Let's look at the right hand side. The right hand side is equal to 1 minus sine squared of 180 plus a, all divided by 1 minus cos of 180 plus a. Now, notice that this is your fraction, so there's a minus sign separating these two here. So let's simplify. We got 1 minus. Now, when you have an exponent, okay, don't get confused. Introduce a bracket here, and there's your exponent now. So what are you actually looking at? You are actually looking at sine of 180 plus a. You're going to write down your answer there. The square will remain there. Do not interfere with the exponent. You work out what's the base of the problem there, which is sine of 180 plus a. So you go to 180 plus. Where is 180 plus? There's 180 plus here. Now, what letter do you see? You see t for tan and 1 divided by tan, which is cot. That means only tan and cot are positive. Is this a tan and a cot? No. That means if it's not tan or cot, that means what you have is negative. So this is going to be minus sine of a within brackets. Can you see that? Because you still got that exponent there. Now, there's my division there. Then I got a 1 minus again. So what are we dealing with now? We are dealing with cos of 180 plus a. So you go to 180 plus. Only tan and cot are positive here. You do not have tan and cot. You have cos. So what will cos be? Cos will be negative. So they're in brackets. It must be in brackets. That will be minus cos a. You're clear with that? So now you can simplify. So this is equal to 1 minus. What's happening here now? You got a square. You are squaring everything inside the bracket here. So when you square the negative, it will become positive. When you square sine, that will become just sine squared. Now follow? Now in the denominator, you got 1 minus will be plus cos A. Okay, now what can we do here? We need to simplify further. We need to prove that this whole thing here is equal to just cos. What can we do here? What we can do is, we notice that this is 1 plus cos A and the numerator is just sine squared. So from our square identities, we know that sine squared A plus cos squared A is equal to 1. So sine squared A is equal to 1 minus cos squared A. So that's exactly what I'm going to do now. So therefore, 1 minus cos squared A all divided by 1 plus cos A. Now be careful, a common mistake that students make is that you will try and cancel this. Okay, you cannot cancel the cos with cos on the top because there's a plus sign separating and there's a minus sign separating. So you cannot cancel terms. You have to factorize first and then you can cancel only factors. So if you look at this part here, 1 minus cos squared A is the same as writing 1 squared minus cos A all squared. 1 squared is 1. So what do you notice about this here? These two here and then these two exponents and this sign. What do you remember for that? It's a difference of two squares. So what we have there is A squared minus B squared. The difference of two squares. So this can be written as A minus B, A plus B. So let's do it here. So all I'm going to do is factorize 1 minus cos squared. That will become 1 minus cos, 1 plus cos. And now it is factorized. Now it is possible to cancel 1 plus cos with 1 plus cos. So let's see what remains now. So if I cancel that, we need to be very careful with this here. When I cancel these two here, I have a 1 minus, can you see there's my 1 minus, and what remains now? What remains is 1 minus cos A within brackets. If there's no brackets, this is wrong. So now I can remove the brackets. So there will be a 1. Minus times 1 will be minus 1. Minus 1 times minus cos A will be positive cos A. What happens here? 1 and minus 1 cancel. So I end up with just cos A, which is equal to the left hand side. And that's your 6 marks there. Okay, the next one here, 6.3, you're given this diagram. There was a question about a person standing at point C. The surveyor wants to determine the height of tower AB, and you are told the angle of elevation from where the person is standing to the top of the tower is 56 degrees, and from another position 20 meters away from this point, the angle of elevation here to the top of the tower is 74 degrees. We need to find the height of the tower. Okay, so what information do we have? So the most amount of information that we have here is the information where we have the side DC. Can you see that? So we have a side, we have an angle, not enough information. Okay, we cannot work out with just one angle and one side. What can we work out? So can we get more information? So what we are told is that B, D and C are on the same horizontal. Okay, so the horizontal. That means this is a straight line. Okay, they are all on the same horizontal plane. That means this is a straight line. So let's call let's call this D1. Let's call that D2. Alright. Why am I doing that? Because I can use this information, 74 degrees, in order to work out this angle here. Can you see that? How will I do that? 180 minus, because the angles in a straight line, if you measure the angle, it's 180 degrees. Okay, so let's write down D2 is equal to 180 degrees minus 74 degrees. The reason there is BDC is a straight line. That is the reason why you are subtracting 180 minus 74. Okay, there must be a reason for everything that you are doing. So 180 minus 74 is 106 degrees. So I'm calling it D2. So remember that D2 is actually the angle ADC. Okay. Because D2 was not labeled on the diagram, you understand that? I decided now to call this one D1, D2. According to the diagram, it's angle ADC. The one in the middle is the angle. You understand that? Right, so it's actually ADC now. Now we have the 106 degrees. Okay. So now what do we have? We have an triangle going like this here. Okay, we have 56 degrees here. This one is 106 degrees, and this side here is 20 meters. Alright, so now what can I find? What can I find? So, if I have two angles, okay, without reading any other question, you should be finding out the third angle, because 99.9% probability is that you will need this angle in order to continue with the problem. Alright, so we will have to find this angle. Let's find it. So, in triangle, I'm labeling it as ADC. A plus D plus C is equal to 180 degrees. Obviously, the reason there is sum of the angles of the triangle. Okay, angles, I'm just putting L with the S there. It's a short form of writing angles. Right, so sum of the angles of a triangle. So A plus 106 degrees plus 56 degrees is equal to 180 degrees. So A is equal to 180 minus 106 minus 56 degrees. So in other words, you are subtracting 162. 162, so you get 18 degrees. Okay, so now we found that A is 18 degrees. Okay, now, alright, so we got this one here. We found that it's 18 degrees. Now, what should we work out next? What should we work out? 18. Okay, if we work out 18, why would we want to work out 18? You want to work out 18, then what will you do after that? Now, do you have to work out 18? What about AC? Why not work out AC? Look, okay, let's look at the triangle. Now, we want to deal with a right angle triangle. So let's go A, B, C. Okay, the one that you all wanted to work out, sorry, let's go for A, B, D. Okay, you want to work out D because you have the 74 degrees there, correct? And this is a right angle triangle, so you can use SOHCAHTOA. Right, so you have the 74 degrees, you want to work out AD. But now, remember, you can also do this here. A, B, C. Okay, because we have 56 degrees, it's still the same right angle triangle there. Can you see that? So now if I work out AC, I'll have the hypotenuse, and then I can use opposite over hypotenuse. Same thing, here I will have the hypotenuse. So can you see that you have two options here? Right, you don't have to go and work out AD because they both lie in the same, this side and that side all are within one right angle triangle. But since you're asking for working on AD, let's work on AD. Right, so what is AD? Right, so now let's go back here. Let's go back. What is AD? So AD is equal to, we're going to label it as using small letters. Alright, so we can write down the formula here. What is AD? Small letter C. AD is small letter C. AC is small letter D in that diagram there. And DC is small letter A. Okay, now let's write that down. What do we have? Let's write down A. We got A, we got C, and we have D, then we got A, C, and D. So, the capital letters represent all the angles that we have. The small letters will represent the sides. Alright. So, we have all the angles. We have angle A, we have angle C, we have angle D. We have all those angles there. Can you see that? What are we looking for? What do we want to find here? AC. We want to find D. Okay, now what else is given to us? What about that 20 meters? 20 meters is what? Is DC. What is DC? Small letter A. So that means we also have small letter A. So you must have, out of the 4 variables, you must have 3 to work out the fourth one. So, which ones will we use? There's A, small letter A, capital letter A. Definitely, we are using this one here. It's going to be A over sine A. Can you see that? Then, you have D. You have an angle D, so obviously, that is the one we're going So how will you write that down? You can go D over sine D is equal to A over sine A. So now I need to make small letter d the subject of the formula. So what must I do if I want to make small letter d the subject of the formula? I need to multiply by sine d on the left hand side and on the right hand side. So sine d and sine d will cancel. So d is equal to A over sine A multiplied by sine d over 1. You are clear with what I'm doing? I multiplied by sine d, it's just that I didn't show it to you. Sine d and sine d cancel. Whatever I do on the left, I do on the right. Now, d is equal to small letter a. What is small letter a? It's 20 divided by sine of angle A. You can see obviously the angle we had to find it because we're using it now. It is 18 degrees times sine of D. What is angle D? 106 degrees. What do we get? Give me to 5 decimal places now. I want 5 decimal places. So D is equal to 21416. Okay. This is meters. Okay, so now let's transfer this information here. 62,21416 meters. This is not the final answer, so we will not round up to 3 decimal places here. You're clear with that? At least 5 decimal places will be okay for now. So now, we are working with this triangle here. What do we want to find? Yes, please. ABG. Oh, sorry. We are dealing with AG, AC. We're dealing with this one here. ABC. Let me just go back to small letter D. We're dealing with this one here. Oh, right. So that's ABC. So that's my AC, which is D. This one here. That's 62,2141.6 meters. Alright. So we found our AC, which was 62,21416 meters. Now, what are we looking for? We are looking for AB. The question stated, determine the height of tower AB. So now, here we are using the sine rule. Okay. Here we are using the sine rule. And why did we use the sine rule? Because it was a non-right angle triangle. This triangle here, this one here, this is the one we are dealing with now. We are dealing with ADC. So we found AC. Okay, we just found AC there, which is 62,21416. So now we had a non-right angle triangle. So we used the sine rule. We could use the cosine rule also. Right. If you have 2 sides. Now we are dealing with a right angle triangle. So if you're dealing with a right angle triangle, then you need to remember and tone. So now, let's look at the information that's given to us. Since we use this triangle here, the big triangle that we're dealing with. Right, ABC. So, which side are you looking for? You are looking for AB. And how is it related to the angle? It is opposite the angle. Okay, that's the most important. We all know that we're looking for AP. Right, but the main thing is how is it related? How its position with regards to the angle. It is opposite. And what is this side here that's given to us? Hypotenuse. So if you put the opposite and hypotenuse next to each other, it's OH, that means we are using sine. Alright, so now we're going to go sine of 56 degrees is equal to opposite over hypotenuse. My opposite is AB. My hypotenuse is AC. So we're going sine of 56 degrees is equal to opposite, which is AB, hypotenuse, which is 62,21416 meters. And now all I have to do is make AB the subject of the formula. How do I do that? I will multiply by 62,21416 on both sides. In other words, shortcut is just cross multiply. So we got 62,21416 times sine of 56 degrees is equal to AB. Give me the answer now.
51,578.
What's it?
51,578.
Now we will round off to 3 decimal places. 51,578 meters. Indicates that this is the tower. Okay, the last question is you are given these graphs. You are told f of x is equal to a cos x, g of x is equal to sine bx plus c from 0 to 180 degrees. There is 0, 30, 60, 90, 121, 21, 80 there. Determine the values of A, B, and C. So now, A, the easiest one there. What is A going to be? A will be 2. Okay, why? Because you are told that this is a cos graph. Okay, it is a cos graph. It does not have any shift up or down here. Okay, if you see your trig function plus a number, like here, plus a number, then you know now the graph has been shifted up or it could be down. It depends on if it's a positive, it's going up, if it's negative, it will be going down. So we know that this graph here, if it's starting at 2 there, you can see the coefficient of x is also 1. That means this is your basic standard cos graph. Okay, it's a standard cos graph. Then from this is the center. The center is going to be the x-axis. That means from the x-axis going up, it must be 2 units. Going down, it must be also 2 units. But obviously on the negative y-axis, we label -2. So in this case, you have f of x is equal to a cos of 1x, and a, which is your amplitude, is equal to 2. Okay. Now, what about b and c? So let's see what we have here. We have g of x is equal to sine of bx plus c. Now, you have to be sketching your trig graphs to know the difference between what you see here and what is your basic trig graph. So, this graph here, sine of bx, your basic sine graph, how does it look? Your basic sine graph, you're going 0, 90, 180, 270, 360. When you're going up, down, up, and down -1. So you're going 0, 90, 180, 270, 360. This you must have in your head, sine, cos, and tan, your basic graphs. So this here is reaching a maximum of 1, minimum -1. Now, this is your basic graph. This is the graph of y is equal to sine x. Okay. Or x less than or equal to 360, greater than or equal to 0. Now, what we see here is from 0 to 180. Now let's compare the 0 here. Here when x is 0, y was also 0. The problem here is when x is 0, what is y? -1. Okay. So that means this, let's check, okay, that means this has been moved down 1 unit. Can you see that? Let's do it. Let's make sure for the second point. Here for your basic graph, when x is 90, what is y? Y is 1. Okay, when x is 90, your y value here is 1. Here, when x is 90, what is y? 0. So what has happened here? This graph is now shifted 1 unit down. Can you see that? So, the question is, has it been shifted to the left or the right? No. Okay, it's the same x values. The only difference in the position is the y values. Can you see that? So, that means now, first of all, what determines the shift left or right will be what's inside here. So if I got y is equal to sine of maybe ax plus b, and then I got plus c. So if I had something like this here, then this will affect the graph shifting left or right. Also, your frequency here the coefficient of x is 1. So therefore 360 divided by 1 is 360. If you take that, divide it into 4, you get every 90 degrees. And you see that it's the same thing here. You got 0, there's a first quarter 90, second quarter 180. So what we know here is that this b value here is the same as the b value here. So your b is equal to 1. Okay, there's nothing here. So it's just 1x. What has made this graph change is not left or right. Okay, it's still the same basic sine graph, but this graph has been moved 1 unit down. So therefore, C, this value here, bringing it down, what will it be? -1. -1. So you have to look at the original graph and understand what happened from the original graph to any other graph that's given to you. Alright. So your C is -1 there, so therefore g of x is equal to sine x minus 1. Now, let's answer the last question. Read from the graphs the values of x where a cos bx minus sine bx is equal to c. So, normally in these types of questions, it is not in the order that is given to you, that you see here. Alright, so what you do is separate the two. What do we have here? We have a cos x, and if I take this to the right hand side, it's going to equal to sine bx plus c. So what is a cos x? A cos x is f of x. And what is sine bx plus c? Is g of x. In other words, they could have asked you the question, where is f of x equal to g of x? But they did not ask you straightforward. They gave you where a cos x minus sine bx is equal to c. For you to understand, you need to interpret this question and understand that it just means where is f of x equal to g of x. That means where do the graphs intersect? They could have just asked you, where do the graphs intersect? Okay, but they asked you in this way. They could have asked you, where is f of x equal to g of x? But they did not. They asked you, where is a cos x minus sine bx equal to c? Now, there's only one place the graphs intersected. Where is it? At 90 degrees. So, x must equal to 90 degrees. That is all. That's why it's 1 mark. It's 1 mark. It's a simple thing. It depends on how you ask the question. It's clear, everyone can see that it's 90 degrees. But when it's given to you in this form, it's given to you, you must be able to rearrange it to see that one graph is f of x, the other one is just g of x. Alright, so yeah, that's basically it. If there's any more questions, for those of you, this I'm going to post on YouTube, you can always send those questions or under the comments for this video. If you are going over any, it depends on which college you're from, if you are going over papers, past exam papers and stuff, yeah, you send your questions.